Well, good morning, everybody, or good afternoon, good evening, wherever you may be in the world. It's 10 past 5 p.m. Over in the UK, so approaching my evening and feeding time at the zoo for my three children. So I'll have that to deal with after this. So yes, as Deborah kindly said, um, my name is Paul Andrew. I'm joining you from the UK. I decided to make the silly mistake of founding my own company over in the UK now, Cloud Formations, which is the small data consultancy practice that I now work for and support as a director. Just by kind of further introductions to me, I've been a Microsoft Data Platform MVP for 7 years now. Hopefully, be renewed for the 8th time next month. Please feel free to reach out to me on social media. I use Mr. Paul Andrew for most of my handles and blog and all the usual stuff. Interestingly, I can date myself by technology, as I'm sure most of you can, and my career started in the healthcare sector over in the UK, working with SQL Server 2000. I actually started life putting VB scripts into DTS packages in SQL Server 2000 to get them to rewrite themselves with some metadata, which was always good fun. And of course, I've done quite a lot with technology ever since then. I tell my children that I'm older than Google, which often raises some eyebrows. I tell them that I know what a 3.5-inch floppy disk is. I tell them what a dial-up modem sounds like. And of course, they have no idea what I'm talking about because, the next generation. The best part of my job, though, now, of course, is not what I do day to day, but it's the fact that I get to share that knowledge with you guys in the community. And I genuinely enjoy doing that. So I now travel the world and attend various conferences because, yeah, it's great to pass that knowledge on. It's great that the community that we have in this industry where sharing is very much just very part of what we do. It is not the case in lots of other industries that I've looked at and worked with. So great to be here with you, and maybe some shameless self-promotion that I'll actually be over in Copenhagen next week at the Data Platform Next Steps conference, actually delivering a full day's workshop with Microsoft's PM Devang on the real-time intelligence in Fabric. So particularly pertinent, and hey, if you want to get a flight over to Copenhagen, I'll see you there next week. All good. Let's move on then. Let's think about tonight's topic. But before we do, you'll get used to my silly sense of humor. Who's heard of Copilot? And of course, talking to my webcam, I'm sure all of you have heard of Copilot. So I was thinking, well, I'm paying for a Copilot license now as part of my Microsoft tenant. Copilot can help me with these slides that I'm about to show you. This was my intentions. So I said, hey, Copilot, that you'll talk to it like that, but the prompt I gave it was, can you add a slide to my deck talking about the advantages of combining real-time data with batch data in a Lambda architecture? I thought, fairly well-trodden path. We've had this pattern for a while now. I thought it would be able to come up with some good content there for me. And Copilot's response was, it said, sure. I've completed some of your request, but I'll need some more practice before I can do everything in it. I was like, okay, fine. I said, show me the good stuff then. Show me what you've got. I had high expectations. This was kind of my first experience of working with Copilot in this way. So genuinely, this is the slide that Copilot created for me. I thought it was quite good. So I looked at this slide, and there is obviously some useful narrative in here about what a Lambda architecture is and how you can leverage it. But I did some further prompts, and I said, well, this is good. Can you tidy it up a bit? What's this picture? And Copilot's answer was, well, this is a stream. I was like, well, no, I want a data stream. I don't want an actual stream. So yeah, obviously, still a little bit of work for Copilot to do that. But of course, just for amusement in this session, this is what Copilot gave me. This is also great amusement to my wife, who is a geography teacher, and she says, "Oh, you're looking at rivers and streams and things, are you?" And I said, "No, definitely not." Anyway, let's move on. So the session that I want to go through with you tonight, this an engineer's guide. So a bit of introductions, a look at some different things, and the way I want to break this down for you is by covering off a little bit of theory and concepts, looking at some of the tooling and technology that we now have available from Microsoft to do this work, and ultimately, get into a demo and actually get a bit more hands-on with that technology, looking at how we can apply it and implement it, and then we'll draw a few conclusions. Now, I'm sure you can appreciate we want to get through the theory and the boring stuff quite quickly. So I want to get to that demo stuff as soon as possible. The other kind of side thing I'm very much telling myself here is that last time I delivered this session, it was a 100-minute session that I delivered at SQL Bits earlier in the year. We don't have 100 minutes this evening, so we'll see how we get on. But ultimately, reach out to me and we can always go deeper into certain areas as appropriate. So let's start off, and what I want to do is for context with that theory is just kind of dissect our um, title a little bit here. So I say an engineer's guide to data analytics. Let's just think about that firstly, again, just for context. And for context, what we'll do is just ask one more question of, well, what is big data? Because I think this is important context for what we then lead into. And as a consultant, my answer will always be, it depends. This is the consultant's answer. The answer is not 42, it depends, the life, the universe, and everything. Of course, we can go better. So the answer that I like actually comes from Mr. Bookwoody. And the way that Book defined big data was, he said, any data that you cannot process in the time that you have or want, using the technology that you have. And this, I thought, was, yeah, this is definitely a much better answer. Ultimately, what we're saying here is it's relative to what we're trying to do. That's good. Now, as we've evolved, and evolution is definitely a key factor here, we've come to describe that big data with these series of words, these V's, if you like: the volume, the velocity, the variety, the veracity, the value. When I started working with big data, we had three V's. We now have five. I was doing a session with James Serra in Poland, and I think we had six. And then he said, "Oh, there's eight now," and it's like, we'll settle with five. I think five is good enough, because really, it's those first three that I think are the most important. And of course, our focus this evening, your lunchtime, whatever, will very much be on that velocity of that data, the speed at which we can handle that data. Alongside that, the volume of the data and the variety, thinking about the structure of it, is obviously certainly important as well. But, this is how we're setting that context for now with data analytics. The next question that I'll pose for you rhetorically is, well, what is the goal of our data solutions? And that goal, that problem, if you like, hasn't really changed. Certainly since I started my career, it hasn't changed. We have our data sources and we want to get insight from that data. And as I'm sure we appreciate, data becomes information, information becomes knowledge, and knowledge becomes power. And we want power. Power is good. But to get there, we need something in the middle. How do we deliver that insight? And despite what our managers and C-suite people might think, this is not magic. We can tell them it's magic, but it's not. The thing that we need in the middle, or at least what we're going to start with here, is what we called a data warehouse. And I think this was good. I don't think there was anything wrong with that. I like to describe it as a data warehouse, but it was that thing in the middle that meant that we could get from the data source to that insight. And what we asked of that data warehouse was that we cleaned the data, we translated it, transformed it, modeled it, analyzed it, all of these things, whatever we might need to do to deliver that insight to inform our business decisions. All good, just context. I'm sure I'm not telling you anything you don't already know. Now, if we think about our humble databases. We came to describe this as a pattern with our OLTP, our online transactional processing systems in our sources, and then our data warehouse on the right. All good, nothing wrong with that. Maybe we did this with SQL Server once upon a time, or still do. Again, nothing wrong with it, but the problem hasn't changed, is my point here, however we want to articulate it. Now, as technology has evolved, and we think about maybe doing this with a humble DBMS, what we might say is, well, we've got a pain point here now because of that big data. The volume of it, the velocity of it, the variety of it, this is not really what we want anymore because our DBMS is only going to scale up, whereas now we want to consider scaling out so we can process more. So of course we evolve our solution to what we now might call a lakehouse. We now take our DBMS and instead of using that, we might use a data lake. We might structure the data in that data lake using the open standard Delta Lake. We might also use Spark as the compute to help us. We now have distributed storage, distributed compute. We can scale out, we can start addressing those big data problems. Now, the patterns, the fundamental problem of gaining insight also hasn't changed. You might also find in some of my more cynical abstracts of sessions I've submitted to conferences, data where lake, beach, house, lakes, or whatever you want to call it. You get the idea. The problem hasn't changed though. We just get to play around with the technology and the words because that's what we like to do. Now, as a pattern, what we could say is that in my very grey data warehouse world that came before it, we might still approach it in the same way. And we might say, yeah, well, I've got my data sources and my data insight. But because we're now using this cloud native technology, and what computer science tells us is that we want to decouple that compute and that storage. We want to scale out. We want to have things separated because that means we can do more with it. We're not limited in the same ways, given our problems that we're now facing with big data, perhaps. So again, I don't think I'm telling you anything new, but just for context. On a timeline, as I said to you, my career started around sort of SQL Server 2000, and we evolved with every version since then. And of course, in February 2010, everything became a bit more cloudy. Everything became a bit more azure, a bit more blue, shall we say. Now, it's all good. Technology evolves. The problem doesn't really change though. So I thought about this and I thought, well, sure, we have our data warehouse that we built on premises, maybe with SQL Server. And then we have the blue version that came after it. And really, it's just kind of reiterating that point. We're evolving from a data warehouse to a lake house, if we want to call it that. Fine. We're just separating out that compute and that storage and that orchestration to deliver that insight. So let's take that and let's call this my first reference architecture. There are many like it. This one is mine. I printed off my first reference architecture. I showed my mum. She put it on the fridge. It was a proud day. It was all good. Now, this was my first reference architecture. Microsoft also have what they call their components of a big data architecture, big being kind of relative here. Now, Microsoft obviously copied mine. I did mine first, but ultimately, we see similar things here. We see the data sources on the left. We see the analytics and the reporting on the right. We want to get to that insight. We have our orchestration. Now, the interesting probably point and separation, particularly relevant for this talk, is that we're now breaking apart the batch processing and the real-time processing, the streaming. Oh, getting feedback from somebody, if you could mute, please. So we're doing that, all good. And really what I want to do is use this now as a pattern to inform the rest of what we want to talk about this evening. So we're going to focus very much on that data source part, the real-time message ingestion part, our stream processing, a little bit on the analytical store, and then the reporting that comes after it. So we're setting that context of this is what we want to think about today. So let me come back to that original title and let's just kind of dissect it the other way now, because I think it's important to do so. So we've covered off that very overly simplistic, slightly generic guide to data analytics as an engineer. Let's just think about that real-time data portion. Now, I think it's important to define what we mean by real-time data. And the reason I say this is because I've worked in lots of different industry verticals, and a bit like big data, it becomes relative. To a retail customer, 5 minutes is considered real time to them. You know, it's retail, they don't really mind too much. They just want to know how much stuff they're selling so they can buy some more stock, maybe as a use case. In the finance sector, when we're thinking about trading and investment banking, you know, we're talking sub-second, you know, millisecond latency of what they would consider real time. So we obviously have discrepancies depending on the industry we're working with, depending on the use cases that we're delivering. So what I want to do for you is just build on what we talked about with that big data definition and actually just create some good definitions now for what we might think of as real-time data. The way to think about that is I'm going to say that we have some producers on the left, we have some consumers on the right. Producers and consumers, depending on your terminology, I don't mind. I do like a data mesh architecture. I like these terms, so we'll go with it. And really what we're saying is that on the left, we have the point the data is born. That data might be submitted by a front-end application or a sensor or some software that's measuring something. I don't know. We don't mind. But what we're saying is that the data is born and then maybe there's a transaction that's committed or the data exists in some form. Fine. We know in the middle that we might need to do something to ingest that data, to transform it and maybe make it useful or even just receive it from the platform. On the right, we have our decision makers, and we have that data and those insights displayed in a form that they can make decisions from. Fine. So in my overly simplistic scenario, I appreciate, what do we mean by real-time data? You know, it's that getting of the values from left to right. Now, what I want to do is the definition I want to put before you, right or wrong, building on what I heard from Buck Woody when we thought about the big data, I want to build on that definition because there it was relative. I want to build on that definition thinking about the technology that we have because it's important. We're going to build on that, and this is what I'm going to give to you as my answer. What do we mean by real-time data? Delivering data from the producer to the consumer as fast as possible using the technology that we have, that you have. And I think that's a good start. We want to get it to our consumers as fast as possible. Now, it means then that we can be relative with that, whether we're dealing with finance or retail or any other industry, we can be relative with that. I think fine. Let's go a little further because I think what then becomes more common is to say, what do we mean by near real-time data? And I think that's where we end up in a slightly better position when it comes to understanding the requirements of our customers or what they're trying to do. So given what we thought about real-time data of as fast as possible, what I'm going to say is as near real-time data, same thing, delivering the data from the producer to the consumer. But what I'm going to say now is within 1 minute of that data being created or being born, if you like. And I think if we can agree, or at least agree with our customer based on a use case, that if 1 minute is acceptable, then good, that gives us plenty of options. And I say this because depending on the customers I work with, if 1 minute is not acceptable, then just through natural latency and network connectivity and all those other things that might need to happen to make that data useful for the decision makers, then if they need less than 1 minute, then yeah, we're very then limited in the tools that we have available. So I use these definitions to kind of tease out what does the customer actually mean by real time. Lastly, let's think about what we mean by a data stream. Now, building on my previous one, I'm going to simply say that it's data that is constantly flowing from the producer to the consumer. And when I say constantly flowing, if we had a sensor somewhere doing whatever, is that sensor going to consistently send me a reading every second? It could be a zero value, but it's sending me a reading. It's not reacting to an event. It's not a tolerance that's then firing off something that then means I need to do something with it. Constantly flowing, I think, is important. Very much like my stream picture that I had earlier. So it's that constant flowing of data that I want to be clear about. All good. Theory, concepts, taken care of, at least context and background for what I want to share with you this evening. So let's go further then. Let's think about the fun stuff now. Let's think about the tooling. The tooling in Microsoft Azure, firstly. This is an engineer's guide. So let's think about all those different tools that we might use. If we come back to this picture, our big data architecture from Microsoft and their guide, I do believe it was James Serra that created this when I was chatting to him in Poland the other week, and I think this was his picture. I said, yeah, all good. But what we're going to do this evening is we're going to focus on these parts, as I've already said. So let's tidy up the slide a little bit. What I'm also going to do here is I'm just going to put in some vertical lanes of what we might want to focus on, particularly in the context of the tools that we've got available to help us kind of understand, well, what goes where, what can we connect to what we might do maybe as an architect to figure out how we get from left to right. Now, in saying that, I think there is some room for improvement, possibly. With a reference architecture, we don't want to start solutionizing and thinking about the tools straight away, but we probably do also want to think about some of those problems. Latency and that idea of real time is certainly one of those problems. So the way we might come at that is to say that in this picture, I might want to add a box for edge processing. I'm not settled on the naming here, but hopefully you get the idea that if we've got a low latency situation or where we need to respond to something closer to the edge without needing to do a round trip from a public cloud region, then that could be an option, or that could be something that we need. We might want to think about in our tooling. On the other side, we might think about, well, what else are we going to do here beyond the analytics and reporting? And as I'm sure you've gathered from what we now have available in Fabric, we'll get there, but we might also say that there's something that we might want to add on the other end here around triggered outputs or something we react to, some actions that we want to take based on something that's occurred. I think that's reasonable to extend the architecture in that way as well, but yeah, it's an evolution. We'll figure it out. So let's turn our attention to the tooling then, the resources that we have in the context of Azure. The first one might be our Azure stack, our HD Insights, HD Insight, HCI stack. They rename it. It's Microsoft, right? They change the names all the time. But we might consider that near our data sources with our edge processing. Fine. If we move along, we might consider using an Azure Event Hub, an Azure IoT Hub, maybe even an Azure Service Bus, possibly. We might think about using Azure Stream Analytics. We might want to use Azure Databricks, maybe Azure Data Explorer, maybe even Azure Synapse Analytics in there as well. All things, of course, that start with Azure at this point. For the analytical store, maybe we're going to use our data lake, certainly structured with Delta Lake tables. maybe SQL Server in there as well, an Azure SQL DB. Maybe we include Power BI. Maybe we use something that Microsoft offered that they called Time Series Insights. It was a good tool. It meant that we could consume data from an event hub and quickly visualize it and do things with it. But I think probably not a popular tool going forward. We might consider having a Cosmos database in here, very good at rapid transactions if we've got high throughput. And maybe from Cosmos, we might think about using some Azure functions or using the API manager to create something to do some other work. Again, these are all the options. I'm just kind of giving you all of them for now, because then we can think about, well, guiding what do we want to connect to what. This is your guide, or at least the guide I'm giving you to try and think about how we get from left to right in this picture to deliver that insight. So let's pick on some of these tools and let's think about what we could do, why we might use them. Starting with our Event Hub. Our Event Hub is a one-directional messaging resource. It can auto scale for us. It can offer dedicated compute. It can do things that mean that we can support direct message capture from the point of it being received. I'll show you this when we get into the demo. That can be in Avro or in Delta format now. It's in preview, but we have that capability if we want it. So, as a endpoint for our real-time message ingestion, it's definitely a popular choice. If we consider it compared to our IoT hub, we get some slight differences there depending on the use case. Our IoT hub gives us the two-directional messaging. If we want to tell some device that is upstream, go and do an update, go and do something, we can send messages back down to it. So it gives us that two-directional capability if we need it. We have device level authentication, but there's some drawbacks that the scaling is not automatic like it is with the Event Hub. We have to configure that scaling. So there's trade-offs depending on what we want to do and why. This is your guide. We might consider a pattern using Cosmos DB. The change feed that we get from our Cosmos DB, it works very well with Azure Functions. I've implemented patterns like this for some travel companies where they want to react to pricing in hotel sales and whatever else travel companies are trying to sell you. So we might use that change feed to then go and do something to react to something quickly based on whatever's happening in that transactional database. We could do that. We might, of course, consider the very mature Azure Databricks. Great service, maybe in a streaming context, not as good, I might argue. We might have some Spark clusters with some Spark streaming jobs in there. It becomes a bit tricky if the customer says, hey, I want to use the Photon engine because I hear it's really fast, but in a streaming scenario, we're probably not quite there yet, but we've got different options here. We have that limited auto scaling. So things that we might want to think about in the context of that. We might, of course, consider Synapse. Probably not a popular choice now in light of Fabric, but we might consider it. It does give us that more mature unified platform to do the stream processing, maybe in a Spark job, maybe with some KQL as well. We've got our storage there, it's unified. We bring some of that stuff together to make the pattern slightly easier. Sure, we could do. We might bring Cosmos together with Azure Data Explorer. We could do, if we've got lots of time series data that we want to analyze very quickly, two very powerful cloud native tools that we bring together to figure out what we're doing. We could. My favorite, and we'll go a little deeper here, is to use Azure Stream Analytics. It is definitely a favorite because it supports the crowd-pleasing demo that you will be pleased by a bit later on of live dashboards and visualizations. We can aggregate data. We can do things based on windowing. we have a SQL-like dialect. And I like SQL. I've spent my career with SQL. SQL is good. We can include references and custom functions. We can do scoring and all these other great things. And when I started putting the bullet points on this slide, thinking about Stream Analytics, I thought, oh, I'm not really doing it justice here with a few bullet points. We need to go a little deeper. So that's what we're going to do as a slight digression, but hopefully it's going to give you some good context for how things have evolved and how we might apply them moving forward. So let's go a little deeper into Stream Analytics just for now. With Stream Analytics, we have some inputs. Maybe that's from our Azure Event Hub, maybe from our IoT Hub. I don't mind. We have some outputs, maybe to Cosmos, maybe to SQL, definitely to Power BI dashboards, because that's really great when you do that. And maybe to some other Azure resources as well. Now, the way that Stream Analytics was introduced to me, thinking about a data stream, is the fact that in a data stream, it's the query that doesn't change. It's the data that's changing. By comparison, if we think about a batch process, maybe in a SQL database, the data doesn't change relatively. You know, a batch process that we've loaded daily, weekly, monthly, whatever. We've done that load, the data doesn't change. We write different queries to aggregate it, to select different columns, to join or whatever. We're changing the query, not the data. In our stream, the data is changing, the query becomes fixed at the point the job is started. So we have some data, we have it streaming using PowerPoint animations, of course. Look at it go. Isn't it glorious? The data's moving. The query is fixed in the middle. What does that query look like? Well, it could look like this. It looks like SQL. Great. I like that. I can write a SQL query in here. Now you might notice some subtleties in how the query is structured. I have a from clause from my inputs. I have an into clause. The data is going into my outputs. Fine, I can get on board with that. We're not creating new tables here. We're just going from input to output. We have a group by clause, which we'll get into. What we might also do in here is add some reference data to our Stream Analytics job, maybe from a CSV file, maybe a dimension for product data. We can include that in our query with the dialect that we're used to and in a join, joining on the product ID. Now, just for amusement, I do put my commas at the end of my attributes. That's what I like to do. Anyway, because that's the right way to do it. Let's argue about it. No, not really. What we can also do in our Stream Analytics job is have user-defined functions that we create for some reason in JavaScript. I'm not sure why we create them in JavaScript. I've asked Microsoft, I said, why is JavaScript the language that we create our UDFs in here? And I didn't really get an answer, but you can do. So we can create JavaScript and we can then use that JavaScript inline to do things as part of our SQL query if we wanted to. A SQL query, I've already fell into the trap, right? Because that's what it looks like. A Stream Analytics query. So for completeness, we say that we have source data, we have reference data, maybe we have some custom functions. And that's what we put in the middle of our Stream Analytics job. That's not all. That query, as you might have seen, is not just one result set. It could be an aggregation that we use and we create by defining a window. Not Windows, not Microsoft Windows. Let's not go there. A window that we define using different properties. And we have sliding windows, we have tumbling windows, we have hopping windows. And to quote the Microsoft documentation, a window contains event data along a timeline that enables you to perform various operations against the events within that window. I think we definitely overused the word window there, but you get the idea. So again, using the amazement that is PowerPoint animations, a guilty pleasure of mine. Sorry, I'm inflicting this on you. Here we have our
Paul,
sliding window. Yes,
sorry to
hello.
interrupt, Paul. It looks like there's a
Right.
question in the chat. Someone's asking, is Azure Steam Analytics a data mart? By looking at query, it looks like it has aggregated data specific to business usage.
It's not a data mart. I wouldn't describe it in that way. It's just a mechanism to get real-time data in event form, in message form, from the inputs here to the outputs. The query is also fixed, and I'd probably think about a data mart as being a much larger data set of things that we want to create. It's not that. It's just giving us that ability to connect that real-time feed to something downstream to maybe perform further analytics on it. That'll probably be my answer for now. Interesting question though.
Thank you.
Let's move on with some more amazing PowerPoint animations if we think about a tumbling window. A tumbling window here, as we'll see, it's taking that definition in our group by clause and we're just tumbling with that. So instead of sliding based on the data that's coming through, we're just tumbling now to capture that aggregation for this offset. And last but not least, our hopping window, which, as you can imagine what's going to happen here. The only difference between our tumbling window and our hopping window is that we can define an overlap, the hop overlap, as part of the syntax that we create in the group by clause. So all good. So we, in our Stream Analytics job, define that query window in whatever form makes sense for us. We don't have to have a query window. We don't have to have a group by clause on there. We can just do select star into and from. It's all good. The other limitation to be mindful of is that in that query window, you can have a maximum window size of 7 days. Now I think about that and I think, well, that's not really a limitation. If I'm doing a query window of 7 days, then that's more of a batch process than a streaming process. So I think that's fine, but just be mindful of it. So that's Stream Analytics. And that really kind of concludes what I want to just offer you for now in terms of tooling when we think about Azure. We'll show you and demonstrate some of this in a moment, but for now, these are the tools. I say this is your guide to what we might do with a few different patterns to handle it in Azure, and we'll demonstrate some of them. Let's
It
turn
looks
our
like we have
attention.
one more question. Sorry.
It's okay. Yeah, go ahead.
Someone has a question in there. Does it run SQL windowing functions on non-time columns?
Does it run SQL windowing functions on non-time columns? No, I think is the answer, but I would need to check that. But yeah, it's it's not it's not windowing functions in the same sense of how you might do a row number or a rank and kind of partitioning by, because it's a data stream, you know, so the query's fixed. It's a window in the sense of that timeline and the data that's flowing through it. So yeah, not a windowing function in that same sense. It's this is probably a you know a criticism of the tool that we're using a SQL-like language to define that query in the middle. We're not writing a true T-SQL query. That's not what we're doing. So yeah, no, and hopefully that kind of gives you some context of why. But definitely, I appreciate the confusion there. So yeah, good question. Um, let's think about Fabric then. I'm sure a bit like Copilot, you've all heard of Fabric, and I'm certainly not going to kind of go through everything here of, well, what is Microsoft Fabric? There's certainly plenty of content out there. But I think the definitions that I do like is these from Microsoft, where they say it's that end-to-end analytics solution. Fine. What Microsoft says, it's also the fact that we no longer have to stitch together those individual analytics services. I call that one out from the Microsoft marketing people because amusingly to me it was the same message that we got when they delivered Synapse. It was the exact same message. We no longer have to stitch together individual things. and that was how Synapse was sold. Fabric is we're doing even less stitching, and now because it's fabric, we can play on the wording there. I don't know, but hey, fabric is that evolution of this technology stack, making things easier for us as data plumbers in the unified product. Now, the perspective that we might have on it here is that, fabric can do lots of things. It has lots of different experiences now. We're of course not going to go through all of them, so I'm just going to put some one-liners on the screen for you. Our focus, of course, today is very much going to be on what's now called real-time intelligence. And we'll obviously look at that and apply that to our pictures momentarily. But what I would say is it's the evolution that I kind of want to play on here, because for every Microsoft Fabric experience, in most cases, we have a comparable resource in Azure because we're evolving. There's lots of good parts of Fabric now and lots of innovation that's in there when it comes to data ingestion and serving. But if you want a starting point of understanding what Fabric is, I'm offering you this kind of perspective of here's what each of those experiences can do. If you've got experience yourself with previous Azure resources, then this is how you could think about it. All good. Let's move on then. Let's move on and come back to this picture. Now, I want to be very clear here about the Fabric tooling before Microsoft Build. Hopefully you attended some of the Microsoft Build sessions. I did over in the UK. I was up till 1 and 2 o'clock most mornings listening to them, so sympathy please, but hey. So before Microsoft Build, when I thought about real-time data and I thought about Fabric, this is how I kind of laid out my picture for you. We have our Data Explorer, our KQL capabilities, and we have our data engineering and we have our Spark streaming. But as you'll probably gather is I felt that our real-time message ingestion, it was lacking. It was lacking in the sense that it didn't have its own experience, because at the time, what was real-time analytics, not real-time intelligence, more Microsoft renaming, we had real-time analytics that was just Data Explorer and KQL queries, and that didn't always fulfill exactly what I wanted, certainly if you compare it to the Azure tooling. What we did have, though, was an item, not an experience, just an item that was an event stream. It still is an event stream, actually. No renaming there yet. So this is what we had before Microsoft Build. Again, there's an evolution here, which is why I'm kind of calling it out. Now, after Microsoft Build, what I've very crudely dumped into my picture, because this seemed like the most appropriate way to dump it into the picture, is what Microsoft are now calling their real-time hub. So we now have that real-time hub as a first-class experience, which ultimately is what we needed. That's what we were lacking. And what we see in here is our event stream. We now have an event house. We now have real-time dashboards. And of course, we have reflexes created in Data Activator. Fine. But like I said to you with the previous comparison, it's like, well, there's an evolution here. Our event stream as a Fabric item is simply just our event hub and our stream analytics combined, which is why I kind of went into a bit more detail there around stream analytics, because it's an important capability to know about. We don't have feature parity yet, but that event stream artifact is exactly that. It's those two Azure resources brought together in a nicely packaged way to make it easier for us to get going and deliver that insight. Our event house is an evolution of our Azure event grid, considering that publisher subscriber model of doing things. What we might have had once upon a time in Azure Data Factory, if a file was created in blob storage, that creation event meant that we triggered a pipeline. We have the same thing here in the context of our event house. subscribing to external events, which means that we can trigger and do something in our solution to help us with our data processing or otherwise. We still have, of course, real-time analytics in there, featured now, and kind of considering that pointer to our Azure Data Explorer resource as well. But this is kind of where we are now. So this is my guide that I'm hopefully giving to you. It's that evolution of the tooling, but it's also, this is how we could apply the tooling to deliver that insight. All good. Let's move on. Let's get out of the slides for a bit. We're done with slides. I'm sure you're probably done with slides as well. So let's just change a few things around here on my screen and we'll get into something a little more interesting. Oh, no, we won't. Sorry. More slides. More slides because I put some AI generated pictures in here. And of course, we love AI generated pictures, right? Yes, Paul, I can feel you all nodding. Our use case. Our use case is that we are the owners of a bike shop, a cycle shop, if you will. Hopefully this is a common use case, right? Now, I have no idea why Midjourney cannot correctly spell things in an image when you correctly spell what you've told it. I thought I'd got it wrong. I do genuinely get spelling wrong, but hey, we have our shop, AdventureWorks. In our shop, we have lots of products and we have a till, a point of sale device where we want to know what's been sold, the products that have been purchased by our customers. We have our corporate head offices, which is apparently, this is what they look like according to our AI image generation. In our corporate offices, we've got lots of dashboards in the main operations room and all the things from all of our AdventureWorks shops that we have all around the country. There's loads of them, of course. And then we have the office of our CEO, because that's what this looks like, apparently. This is our CEO's office, and he has some information from that real-time feed about which shops, of course, are performing the best given the product sales of these things, etc. And what we're going to do is, in my demo, I'm simply going to say that my PC here is going to act as that point of sale device. I have an AdventureWorks database in a SQL instance, because everybody should. I'm going to use a local C# application that's going to poll that database and poll it on a fairly consistent interval, but then kind of generate that real-time feed, if you like. We're going to put it into an event hub. We're going to capture it in our storage. I'm also going to show you a useful tool in VS Code where we can just inspect what's in that event hub. And we're going to bring in some CSV data as well. And from that stream analytics job that we consume from our event hub, we're going to send that data out to Power BI. So given the use case in my AI image generations there, this is what we're going to build. And then if we're lucky, we'll also look at creating the same thing, or here's one I made earlier, style in Microsoft Fabric. Now in my 100-minute session at SQL Bits, I did this live on stage and I built these things and I got people to follow along. As we don't have that time today, then I say we'll cheat a little bit. Awesome. So that's what we're going to do. Now let me change things over so you can actually see my screen. So what we have here, our Azure portal. Firstly, what we also have as promised is in my SQL instance, I have an AdventureWorks database. I have the sales order details table, so this is the things that my point of sale device is kind of capturing, as you can appreciate. So these are the sales, the product ID, the unit price, etc. What I also have is a little bit of metadata just to kind of help me out here. So I've got some connection string information. And the reason for this is because when we do this as part of a workshop, I get people to give me their connection string information and I send these messages out to them as well. So it's great fun. I play point of sales for all of the people that we're building this with. So I've got a couple of connection strings in here for Azure and for Fabric. Nothing too exciting. I then have a little bit of C#, as mentioned. This C# is simply getting the connection information from my database. We're creating a feed to my Azure Event Hub, and I'm taking a random row. It says confidently, there's my select star look. Don't do select star, that's really bad. But we have another query down here. I'm just doing a select top one from my, wherever it is, from my sales order detail table, and I'm just doing missed it. I'm doing an order by new ID just to get a fairly randomized value, just for the point of demonstration purposes here. So I'm just going to kick that off for now, and I have a nice console that's just going to say it's sending data to my Event Hub. All good. In my Azure portal then, let's check out my dashboard. Let's do a bit of a refresh here. I was obviously testing this earlier. And I have my Event Hub, and I have some messages flowing in. Now, the thing that I wanted to show you, as a slight aside here, is that if I've deployed this Event Hub, the Event Hub namespace, maybe to be clear, so we have a namespace as the resource. We then have event hubs within that namespace. So within my Event Hub, I've got some connection information that I've captured and that I've used in my database and otherwise. But what I can also do is, if I want to just look at the data that's coming in, I can drop into VS Code. There's quite a nice extension that I don't think's been updated for a while, but it still works. So there's this extension called the Azure Event Hub Explorer. Now, what that means I can do is that if I just select my Event Hub, assuming that I'm authenticated against my subscription, I can just select the namespace, I can select the hub, and then F1 again. I can start monitoring the Event Hub messages in my output. And what you'll see here is that value, that randomized row that's been taken from the SQL database, pushed to my Event Hub. You can see based on my console app, they're kind of just flowing through nicely at the moment. I'm falsifying the real-time stream. All good. I'm just going to stop that because I've only got the default consumer group in my Event Hub, and just as an aside there. The next thing to look at is my Stream Analytics job. So in my Stream Analytics job, I have the inputs, as I suggested to you. The inputs in this case being my Event Hub. The fields are grayed out because the job is started, but I have the Event Hub there. I also have some reference data. So what I've done is I've put a CSV file in that blob storage, which means that my product ID is the attribute I was thinking of. The product ID is going to be resolved to something meaningful as part of my stream, and then I can do something with that. I have an output, in this case, to Power BI, or the Power BI experience within Fabric, if we want to be clear about that. And then I have my query in the middle. My query in the middle, very much like what I showed you in the slides. I'm selecting my attributes, I'm doing some aggregations, doing a record count. That data is going into my Power BI outputs from my Event Hub. I'm doing some joins and I'm getting something like this. So my job has started now. And what that means is if I jump over to Power BI or to Fabric, we only care about the Power BI part for this first section, is I can see, hopefully with my messages still flowing in this dashboard based on this data set that's appeared. There's a interesting kind of problem here, is that in your Stream Analytics job, if you've created everything correctly with your output and that data is flowing into Power BI, then that streaming data set will just appear in Power BI. If you've not done it right, it just won't appear. And you end up in a bit of an odd situation there of figuring out, well, what's working and what isn't. But Mine's working, so it has just appeared, and I can then just jump over to my dashboard, and with a bit of a refresh, this is hopefully going to start moving for me. This is always the crowd-pleasing demo of a live dashboard that is now updating with a few aggregations based on the sales that I have from my AdventureWorks database in my bicycle shop. Now, because I'm obviously faking this slightly with that feed of messages, and because I created the C# app, it means that I also have the ability to throttle the message throughput. Wouldn't every salesperson like the ability to just increase their sales? It's like, well, let's do that. So I'm polling the database every 4 seconds. Let's poll it every 2 seconds. Let's get that data moving really quickly. This is great. This is how I want sales for my business. Just slide it and just make it so there's more. You get the idea though. We make it faster, messages flow more, my dashboards move more. And this is for me the great part of Azure Stream Analytics, the fact that we can plumb this together fairly easily. The only bit of code I need at this point is that SQL query that goes in the middle. The rest of it is very much click by click configuration in the Azure portal. All good. As we're in Fabric and that's flowing fairly nicely, what you'll probably have seen in the workspace, I do have an event stream. The event stream here representing that same or equivalent architecture, if you like. The event stream combining, as I said, the Azure Event Hub and Stream Analytics together. The advantage, of course, though, with Fabric is that I now have outputs to my KQL database, to my Lakehouse, to Data Activator, so I can create reflexes based on this. Now, the other important thing to note is that if you want to have the Event Hub embedded as part of your Fabric workspace, what you need to add as an input is a custom app. So I've got a custom app input. The custom app input in Fabric is the Azure Event Hub. Not the one I've already deployed in Azure, a new one that I've deployed and it sits within my Fabric workspace. So my custom app is the Azure Event Hub. For clarity, the Azure IoT Hub and Event Hub listed here, that is if I want to connect to the one that already exists in Azure. I'm not. And as you saw in my database in the connection strings, I'm sending that data to 2 places with my C# application. So my custom app gives me an event hub within Fabric. I have the same connection information. You'll see in the connection string information here, sorry, this one, you have at the end of this the entity path, if I can just capture that. It's that entity path, which is the event hub name. We have the connection string information to the namespace. We have the hub name in the entity path. All good. And then we can pass that through. We can see similar things to what I had in my Stream Analytics job. I can look at the outputs. I can send it off now into 3 different places. So imagine I've created 3 streaming queries in the middle here, but I don't have to write them because this is the joy of Fabric. It's low code. So I've created a select into KQL database from Event Hub. I've done a select into Lakehouse from Event Hub and select into Data Activator. So I've got those 3 outputs. I can look at the, where's it gone here? My KQL. So if I wanted to do similar reporting using KQL, I can do that with a bit of a query in here, looking at those aggregations of that data, joining to some product information that I've loaded into the KQL database. I can achieve the same thing in my Lakehouse if I also want to query that. The thing that's lacking at the moment in Fabric is that real-time dashboard. The event stream item, it can't output to the dashboard in the same way that Stream Analytics can. If I just come back here, look at the outputs that are listed, there's no Power BI dashboard. So I can't get that same real-time feed yet. So I can't do the same crowd-pleasing demo, but you've obviously got other capabilities instead. Is my lakehouse loaded yet? Yeah, same data. I could write some queries to achieve the same thing, get the same results out of it. You get the idea. So there you have a couple of different versions. We talked about the Azure tooling and the Fabric tooling. Here's how you could apply them based on those very crude architecture diagrams that I showed you in the slides. I've got 5 minutes left, so let's just drop back to those slides and kind of wrap up here, and then I'll obviously answer any questions that you guys have. So in terms of conclusions, let me just firstly offer you those definitions in a slightly more crystallized form, side by side. That big data and the technology, it's relative. Connecting those producers and consumers depend on that real-time feed. I would say use these definitions, challenge your customers on what they really mean by real-time data. The chances are it will probably fall into one of these, and it'll help you define what you then need to go and build. This is what I'm saying to you as your guide. This is how we can start guiding what that architecture needs to look like. All good. What I've also included for you in the deck, which yes, I will certainly share with you, is my perspective on if we were to create these patterns as Lambda and Kappa architectures, if we want to think about those concepts and what we might do. I'm not claiming perfection here, and what you'll notice is that I also have some timestamps, if you like. So what did a Lambda architecture look like when Nathan Mars first conceived it in an open source world? What did it look like in Azure as we kind of evolved, and what might we now consider if we're working with Fabric? Do we just plonk the real-time hub in there and let's just say, yeah, okay, we're done there. That's all we need. But we need to think about what's actually possible and what we're trying to create. I'll come back to this one, and I don't like to sit on the fence with it depends. I will simply just call out what my favorites are at the moment when it comes to delivering some of these solutions for my customers. The ones that I've worked with in anger. I've worked with all of them in anger. These are my favorites. The Event Hub, Stream Analytics, Power BI, always a winner because it means I can write something that looks like SQL. Also that I've included in the deck for you, slightly for amusement, but I did some work for one customer once upon a time, and I went through kind of a similar motion, and kind of what inspired this talk a little bit was that guide. And they said, well, create me an architecture diagram that just includes all of the options. They say, you're the architect, give me all of the options for whatever I might want to do with my data. I was like, okay, very much thinking about a real-time pattern here. So I drew them this. And what I tried to kind of point out is that, sure, we can connect everything to everything. But what I also tried to allude to is this idea of a data cooldown, if you like, process latency, if you want to call it that. And I tried to kind of allude to it with the colorations on the lines here of where can we keep the data hot? Where is that data going to be persisted and ultimately cooled down? And then what are they trying to do based on those outputs? So I thought I'd include this picture for you for a little bit of amusement, but also to guide you in what you might want to create beyond the, let's say, slightly simpler pictures that I showed you earlier in the slides. Last couple of things, case studies. We love case studies, right? This was a case study of a project that we delivered for a marketing outreach program. You can obviously kind of digest this. There's a lot more detail if you want to go to our website, look at case studies. This one, particularly proud of this one. The reason I'm proud of this one is because if you did follow some of the Microsoft Build announcements, and you might have seen some videos and stories from a customer called Elcom. Elcom, they do all sorts of stuff with exotic yachts and things like that. But the stories that they told during Microsoft Build, it was actually based on this architecture that I designed. I was a subcontractor at the time, but it was always good to kind of see those stories and some of that work come to fruition on the big stage. So feel free to go and check that out. And then lastly, I have to include this for my sales team to say that, yes, I did some work today. So We are a small consultancy in the UK. Over the many years of experience I've got, I've seen all of the problems. If I can help you with those problems, please reach out to me. It'd be great to have a chat. And with that, folks, I will say thank you very much for listening. Do feel free to connect with me on LinkedIn and drop me an email, whatever social media you prefer. The slides, as promised, and I'll put a link in the chat shortly as well. I created a bit.ly for you, CF-slides. There's already a PDF of them there, along with a PDF of a few other community sessions that I've delivered as well. So please help yourself to those. And with that, I'll say thank you.
Oh, I'm talking on mute here. Thank you so much, Paul, for taking the time to go through that. There was lots of people that were very excited about the session and already were giving feedback on how helpful and useful it is. We will, once you have the slides, actually, there's a link there for the slides. There are some people that were looking for that information. If you want to take that down, you can get the slides there. We also do send the slides out to the group in general. Again, if you have any questions for Paul, please, there's his information there. We'll also provide it in a follow-up email. And we know he has 3 hungry children. So if there's no questions, we will let him get to helping those kiddos out for dinner. And thank you again for joining us. And we hope you join us for a session on July 20th.